Hello everyone. Uh, Now I'm here to discuss about feldspar group of minerals. So basically feldspar group of minerals are having three varieties, that is orthoclase, plagioclase and microcline feldspars. And also they'll be having almost same properties. The physical properties are going to be same, but some of the properties are going to change. For example, like a chemical composition, and also the color is going to change, luster, and as well as the cleavages. So like this, only a few properties are going to change from one sample to or one variety to another variety. So as I have mentioned, all the physical properties, totally we are going to have 13 to 15 physical properties. So we'll start with the chemical composition. So chemical composition also going to vary from one sample or from one variety to another variety. So here I have placed 4 different samples or 4 different types of feldspar. For example, this is microcline feldspar, and this is feldspar plagioclase white, and this is plagioclase feldspar again with a different color, that is grey plagioclase feldspar I have, and here this is feldspar labradorite. So like this, I have 4 samples which I have placed here, and also the properties also going to change. So we'll start with the chemical composition. So chemical composition for microcline feldspar is KAlSi3OH, and also for feldspar plagioclase, and also here white plagioclase feldspar, it is going to have Ca or NaAlSi3OH, because sometimes the calcium is going to replace with the sodium. So that is what we have considered both Na and as well as Ca. And for orthoclase feldspar, the composition is KAlSi3O8. So this is how the composition is going to change from one sample to another sample. It is based on the type, and also habit is going to change because if you take this sample, that is the first sample, plagioclase grey color. So habit is twinned. So like this, twinning you can observe. So basically this habit is going to be very clear if you observe this in the microscope as an optical property, but here physical property also you can observe very clearly. So this gives a twinning. So the bands you can observe, it's like a crisscross bands. So it is not going to have a horizontal, or it may be in a vertical. The bands or the lines which can be observed here on the surface will be in a crisscross. So for that only we used to say it as a twinned habit. And the color is grey, as already mentioned in the sample itself. So based on the appearance, that is grey, and this is again plagioclase, but it is not a grey plagioclase, and it is white plagioclase. And the color is going to change from one sample to another sample. Usually the orthoclase is going to have orange or light pink, and plagioclase usually it will be grey or white, and last is microcline. So this is the third variety of feldspar. It is going to have light pink color. So you can observe here. So it is not like a milky white. This is light pink color. So if you observe, will come to know. So due to light, sometimes you may get a different color, but originally this microcline will be in pink color. And streak, we'll check here. So you take any one of the sample, and if you scratch a mineral, so here you observe it is very clear, means you are not going to have anything here. So now you scratch any one of the edge of a mineral on the streak plate. Yeah, you can observe a small substance which is obtained on the streak plate. Yeah, so this is considered as a streak is present, and the color is white. And next, if you come to the hardness, so for checking of hardness, we are going to use the penknife. So if it is easily scratchable by using your fingernails, then we can consider it as the hardness is very less. But sometimes if you use any penknife or any other mineral in order to scratch, then will be considered as the hardness is more than 6. So like this. So for this feldspar, we'll be using a penknife in order to check the hardness. So if it is, you check once first. Try to remove some particles by using your fingernails. If it is not going to break easily, then will be considered as a hardness is more. And also by applying more force, also you can try by your fingernail. Still if it is not going to break, means you have to use the penknife. So by using the penknife, you will come to know whether it is hard or smooth, like that. Means soft with a smooth surface, like that you will come to know. So according to the standard Mohar scale, as we know, the hardness of feldspar which lies on 6th place, that is hardness is 6. So this is, yeah. So 6 is nothing but by using the penknife, we'll be able to scratch a mineral very easily. And hardness 10 is, as you know, that is diamond. By using penknife also, we'll be not able to scratch the surface of the diamond. And cleavage is 2 sets of perpendicular. As I've already mentioned, cleavage is nothing but the tendency of a mineral to break very easily along with the definite direction. So if you break a mineral, so if it is going to break very easily or very quickly, so we can say it as a perfect cleavage and also good. So if it is not going to break, it needs much more force to break the mineral, we can say it as a imperfect or basal. Yes. So here we have 2 sets of perpendicular. Means when you break a mineral or the tendency of a mineral. So this mineral tendency, how much is to break, whether it can be breakable easily or it is not. So that is what you can get. So if you